We've been given triangle ABC in the diagram here. We've been given that B is the coordinate 3, 0, which is here. We've been given C, the coordinate 9, negative 2. And we've also been told that this line here is the perpendicular bisector of the line BC. So let's think about what that actually means. Perpendicular bisector, the clue is in the phrase. Perpendicular. Well, we know a perpendicular line meets at a 90-degree angle as I've drawn here. Bisector means it cuts in half. So we know that this line BC has been cut in half. So what are we going to need to do? Well, we're going to need to know the gradient of the line BC. We're going to need the perpendicular gradient, which will tell us what the gradient of the dotted line is. And we're not going to know any point on the dotted line except this one here, which is the middle of BC. So we're going to need to get the midpoint. And once we've done that, we can bring together all our information and use y minus b equals mx minus a. So, perpendicular bisector of BC. We've got the point B, 3, 0, and C, 9, minus 2. The first thing I would do is I would label them x1, y1, x2, y2, because that's going to be useful for you going forward. You find the gradient of BC first using your normal formula. y2 subtract y1 over x2 subtract x1. In this example, when you do that, the gradient of BC is going to be negative 2 subtract 0, 9 subtract 3. That equals negative 2 over 6, which equals negative 1 over 3. And that's you completed the first section there on gradient of BC. Because it's perpendicular, we want to get the perpendicular gradient. And our statement that we can write is that m1 times m2 is going to be equal to negative 1. And this is a communication statement that's useful for us. What we can then say from there is we can get our perpendicular gradient. Now I denote that often by this symbol here, which just means perpendicular. Some of you may use different phrases, but that's totally okay, just as long as you're comfortable getting the perpendicular gradient. So what you do is, you take your fraction for the gradient from earlier on, you flip it round, so the 3 moves to the top, the 1 moves to the bottom. Now we don't need to write over 1. We then think about the sign. This was negative, but we want to change that sign to be positive. So therefore, the perpendicular gradient is going to be positive 3. We've done the first two parts. Now we can do the midpoint of BC. So we find the midpoint of BC by using our formula x1 plus x2 over 2 and y1 plus y2 over 2. We then substitute our numbers in. 3 plus 9 over 2, 0 plus negative 2 over 2. Now, a very common mistake to see at this level is for people to add 3 and 0 divide by 2, 9 and negative 2 divide by 2. Please make sure you're adding the x's and you're adding the y's. It's not that you're adding the two values that are in the same coordinate. You're adding the two x's and the two y's. That ends up giving you 12 over 2 and negative 2 over 2, giving you the midpoint as 6, negative 1. So we have got the first 3 points done. We've got the gradient, we've got the perpendicular bisector, and we've got the midpoint. So now we can get the equation of the perpendicular bisector. And that's what I'm going to do in the next slide. So we take our perpendicular bisector 3, we take our midpoint 6, negative 1, and we substitute it into y minus b equals mx minus a. Now when I'm doing the substitution, I like to put it all in first. I then start dealing with the negatives and things like that. So I have y subtract minus 1 equals 3 bracket x minus 6. Two negatives make a positive. Y plus 1 equals 3x subtract 18. I'm going to take away 1 from this left hand side, giving me the final answer, y equals 3x subtract 19. And that is the conclusion to part A. So, if you want to rewatch the video, pause just now, go back, rewind, and watch that again if you're unsure of anything. Now, let's look at part B. So, part B says the line AB, which is here, makes an angle of 45 degrees. So it's going to have a 45-degree angle here with the positive x direction of the x-axis. Find the equation of AB. So, what you should do at this point is think, well, what about angles relates to straight line? And what relates to angles to straight line? M equals tan theta. So what you can do is, you can use m equals tan theta to get the gradient. So we replace theta by 45, and that gives me a gradient of 1, because tan 45 is equal to 1. But we also know the coordinate of b is 3, 0. And what you should remember is, from National 5, if you have got one coordinate and a gradient, you're able to find the equation of the straight line. So we can substitute this into y minus b just like we did before. So y subtract 0 equals 1 bracket x minus 3. Now 1 bracket x minus 3 is quite sloppy. We wouldn't really like to write that, so we can just break the bracket there, making it x subtract 3. And that gives you your final answer for this equation. So when you've got an angle, you know you're going to be using m equals tan theta to help you get the gradient. And once you've got the gradient, you can substitute into y minus b alongside your coordinate. Now, we're going to look at part C finally. So, part C says, find the coordinates of the point of intersection of AB and the perpendicular bisector of BC. This is really common in higher maths. They'll ask you in part A and B to complete some equation work, and you'll essentially be doing simultaneous equations with your two answers to get your final answer for C, and it's no different here. Now, I am aware that there's lots of different strategies to do simultaneous equations. I'm going to take you through two, and hopefully they are able to help you. So, the first one I'm going to do is I'm going to do some elimination. So, we've been given the equation of the perpendicular bisector BC, y equals 3x negative 19, and we've got the line AB is y equals x subtract 3. Now we're going to use our simultaneous equations to find the point of intersection. So what I'm going to do is I'm going to put it into a familiar form from National 5 involving elimination. So I start off with y equals 3x subtract 19, and what I want to do is I want to get my letters to one side and my numbers to the other side. So what I can do here is I can subtract 3x from the right hand side, give me y subtract 3x equals negative 19. On the right, I've got y equals x subtract 3, and what I can do here is I can again get my numbers on the right hand side and my letters on the left by subtracting x, giving me y negative x equals negative 3. And that gives me two simultaneous equations that I can use to then find the values of x and y. Now, there is a load of ways you can do it at this point, so I may be doing it a slightly different way than you might have seen. However, hopefully you can still follow what I'm going to be doing. So, I'm going to choose to try and get rid of these x terms here in the middle. And unfortunately, I can't at the moment because there is a different number here. I would need these numbers to be the same. So what I'm going to do is I'm going to multiply by 3. When I multiply by 3 for the second equation, that's going to change it so that it's got 3 here, and it'll allow me to eliminate. So, the first one's going to stay the same, y subtract 3x equals negative 19. I've called it 3 here, this is just a personal preference, some of you may keep it as 1, that's totally fine. I'm going to multiply this one by 3, 3y subtract 3x equals negative 9. Now, the reason I do this is because the rule that I use each time is if the signs are the same in the middle, we can just subtract, and that is going to lead to them disappearing. Now, when I subtract here, if I did 3 take away 4, I'm going to get negative 2y. So instead, I'm going to just do 4 take away 3. The order in which you do the subtraction doesn't matter, but I always tend to try and do it so that my y value is positive. So if I do that, 3y subtract y is 2y. I already know that these are going to disappear because when it's the same signs, they subtract and they go away. So negative 3x subtract negative 3x is going to end up being 0. And then I do negative 9 subtract negative 19. Now unfortunately that's quite challenging if you're maybe struggling with your negatives, but just watch out, I'll write at the side. Negative 9 subtract negative 19, and that's going to be negative 9 plus 19, and that's going to give you an answer of 10 there, and that's why I'm getting 2y equals 10. So we can then divide by 2, giving me y equals 5, And a very common mistake is for people just to stop there and move on to the next question. But remember, with simultaneous equations, you need two answers. So what we're going to do is, we're going to sub y equals 5 into one of the original equations. It could be any of your equations you've got here. Just go for the easiest one. I personally think the easiest one is y equals x minus 3 here at the top. So what you can do is, you can substitute y equals 5 into that. So y equals x minus 3 is going to become 5 equals x minus 3. I want x on its own, so I can add on 3. If I add 3 here, it's going to be 5 plus 3 equals 8, and that gives you your answer for x. And then just to conclude the question, I can write point of intersection 8, 5. And that's me finished this part C. Now, if you're unsure of anything there, again, pause the video, rewind, look back, and try and see if you can get a handle on what's going on. I'm going to show you an alternate strategy though that you could use for this particular example that may be what some of you are already using. So, what you can do is, this is a form that works when both of your equations are in the form y equals mx plus c. And notice that's what you've got here, because you had y equals 3x minus 19 and y equals x minus 3. Now notice that both equations start in the same way, i.e. y equals, and then it gives you an equation. Therefore, what we can do is, we can set them equal to each other, because if these are both y equals, then 3x minus 19 has got to be equal to x minus 3. And then this becomes a two-sided equation, which you've been dealing with for a few years now if you're studying higher maths. So what you can do is, you can take away x from the right hand side here, and that's going to give you 2x subtract 19 equals negative 3. I then want to get x on its own, so I can add on 19. Then negative 3 plus 19 is going to be 16. And then divide by 2, giving you x equals 8. But again, this is only one of the solutions, you need a second, so you can substitute x equals 8 into one of your equations. I'm going to go for 2 just because it's the easiest one. So y equals x subtract 3, y equals 8 take away 3, y equals 5, giving you the point of intersection 8, 5. Now, just a word of caution on this method, it only works this way nicely if you've got y equals for both of them. If this was 2y equals and this one was 3y equals, it wouldn't work out as nicely because your y's are different values. It only worked out nicely in this one because we had y equals for both of them. So this is a strategy that you can use sometimes, and I know that a lot of people do find this one beneficial. And there are a multitude of different ways to do it as well, which you'll see in various textbooks and various online resources. Hopefully this video helps you. I'm going to record more of these and put them up on the channel. Let me know if there's anything that you would want me to do in the comments below. Thank you.